As with each lesson, it's really helpful once you've been introduced to everything, I've walked through it, to actually see how you would do that then in Excel. So I have the grades listed here, 72, 274s, 376s. So it's exactly like what we had before. So you can always go into the video if you want, pause it for a moment, type this data out so you can follow along. And then to get the deviation, again, that's how far is the grade from the mean. So we first need to get the mean. Because we've already talked about how to go through and get the sum of x, divide by n, I'm just going to go ahead and use the average function. And when I do that, I find that consistent with the visual assessment, it in fact is the case that the mean is 86 in the sample. And when we're looking at this, we can then take this mean that we've obtained and subtract x, which in this case for the first person, their score on x, their grade is 72, minus x bar or minus m, and that's going to be the mean at F2. And what I've done, just a reminder, is I've put a $sign in here. That's noting that I want it to stay stationary on F2. What this allows me to do is copy and paste down this column. So B2 is going to be dynamic. When I copy and paste into C3, it's going to move to B3. And then when I copy and paste into C4, it's going to move to B4. But the F2 is going to always stay on 2 even as I move down this column. Now if I moved across rows, then it would in fact change because I didn't put a $sign in front of the F, which is tracking the row that we're on. So for the moment though, I can do that. I can then just scroll down and it's going to give me those deviations that we saw earlier. And to match with what I told you earlier in the video, we did talk about the sum of the deviations. And again, if I sum those, assuming I've done everything correctly, should see that the sum from C2 to C65, because there were 64 scores, so it stops at 65 because again we used that top row for our labels. When I do that, I do in fact find that it gets 0. Now again, unless I have missing data or I've made an error, it should always be that this equals to 0. So when we're looking at this, it should be the case that this always equals 0. If it doesn't, then you've probably made a mistake and something has happened. Now, again, like we said, that doesn't really help us in describing the variability in the sample. If it always sums to 0, that doesn't really tell us much. So then I can do the square deviations. So here you see that I basically have the same thing, B2 minus F2, and now I've added to the second power. And in case you're not familiar with that, you can hit Shift and 6 and it will give you that little caret. And that says to go ahead and square the value, square the difference. It is important that that difference is in parentheses because if not, it would square the average first and then subtract it from x. So you do need those parentheses. So it says do this difference first, again going back to order of operations, and then square that difference. If you've already done the deviations like we have, you could actually make it even shorter and you could just say square the deviation. However, as you move into later and later exams, I'm not going to always ask for this intermediate step, ask you to do the deviations. Early on, I'll ask you to do them in part because you can always sum them and double check that you're doing everything correctly. Again, if it doesn't add to 0, you've done something wrong, and it's useful to have that check. But once you're comfortable with it, by the time we get past the first exam, really, I don't have you do this step, we just jump to this step. And so this formula is useful for doing that step. However, again, if you are doing that intermediate step and doing the deviation, and of course, just because I don't ask for the deviation, if you're more comfortable, if it's easier to break this down into smaller steps, you can always do the deviation and then just square it in the next column. Again, once you do that, you can then just drag it down, and you should be able to drag either of these formulas. So you can drag from this, or you can drag from this formula either way, and you would end up with the same answers that we see here. So once you get the square deviations, then we can sum those deviations. So those are going to be the sum of squares or the sum of the square deviations. And literally all I'm doing is saying sum, right? So sigma means to sum. And the formula for this is sigma x minus x bar squared. So we're going to sum together everything that's in D2 to D65. And I'm going to add function calls out here so that you can see those in case you need them for reference at a later point. Now, once we have the sum of squares, if we want the average, we then have to say, all right, I want to average those. That's going to give me the variance. And if you want to make this completely right, you can always go in and say format, change that to a superscript. Could also italicize this. Most of the time when I'm doing this, I'm not going to take the time to do that in my Excel documents, but if you wanted to. So I typically save that type of formatting for the final presentation if I'm putting it into a paper. But we're doing the variance. Again, the variance is the average of the sum of squares. Because we're working with a sample, we're going to, instead of dividing by n, we're going to divide by n minus 1 because we want that variance estimate to, as much as possible, estimate the variability that we would expect in the population. Again, we know samples underestimate the variability, so we're going to accommodate that by saying take this sum of squares, that's your numerator, divide by the number of scores. We haven't actually counted in yet, so we could always do count B2 to B65. It should be that it's 64, but we can incorporate that into one step as you become more comfortable. Of course, if you want, you could always still do n as its own separate thing, do the count there, and then double check it that way. So it looks like our variance, the average squared variability, is 42. And that would be for a population. However, given that it's for a sample, we're going to subtract 1, and it ends up being slightly larger, which is what we would expect, and be 42.66667, right? And again, keep in mind you don't want to round too early. So we're going to keep all those decimal points there. More decimal points isn't going to cause you a problem. If you have too few decimal points, that's really where it's going to cause you a problem. However, if you wanted to abbreviate to 4 decimal places, like I mentioned you can do in the homework, then you can go in here, note that it's a number, and tell it exactly the number of decimal places you want it to show. In Excel, it's really going to actually hold more decimal places than that, but that way you can see them. And again, when you report the answer, you round to 2 decimal places, so even if there were 6 decimal places out there, it shouldn't cause you an issue. If you round to 2 decimal places too early, that's really where you get into the issues. Now, let's say that we want to check this. So I'm just going to note it as option 2. There is a built-in formula, and there are actually 2. So there's var.p and var.s. And anybody want to pause and take a shot at guessing what that is, feel free. But var.p is for the population, var.s is for the sample. And again, all it does is it changes that denominator. So are we dividing by n, or are we dividing by n minus 1? In this case, we have a sample. So we're going to say, what is the variance of B2 to B65? And we find that that is consistent with and matches with what we found the other way, which would suggest that we've probably done everything correct. The only way those would match and it be wrong, or the most common way that those match and there's something wrong, is if you've misentered a number. So feel free to double check those. Again, if you're comparing answers with somebody, if you enter the data separately, it should be the case that you wouldn't both make the same error in a data entry, and that gives you a clue. So if you're looking, all your calculations are correct, your formulas are correct, you're still not figuring out why the two of you have a different answer, go back and just look and make sure they didn't make an error in the data entry itself and accidentally type something like 73, in which case, see, they still both match instead of 72, which is what you were supposed to type. And then the last thing is the standard deviation. And so I've already calculated the variance. The standard deviation is simply the square root of the variance. And I find out that the average deviation among these grades is 6.531, well, 6.532 really points if we were going to abbreviate to 2 decimal or 4 decimal places. Now, there is also a formula for standard deviation. And again, as we move forward, feel free to use it. I wouldn't start using it too soon. One, I'm going to ask you for some of these calculations anyway on homeworks and things to make sure you're doing it all correctly. So you're going to need that information. So on some level, the shortcuts wouldn't really save you time, but they do give you a good check. So equals STDEV. Again, you have .P or .S. We're going to go with .S because we're working with a sample. And B2 to B65. And we find that they match, which is what we would expect to happen. So that gives us a pretty good sense of how to do this variability, how to calculate it in Excel, and you also have a beginning understanding of what does this variability represent, where is it coming from, and I look forward to your questions about it in the Q&A discussion board.